Okay, good evening, ladies and gentlemen. This is Roger W. Knight, and we're going to do another series, episode in my series on arithmetic. And this is the simple method of subtraction, a method I learned in school, and we'll do this really quick and easy. What we have here on this clipboard is the number 5,280 minus 1,760. How do we do this? Well, 0 from 0 is 0, so we put a 0 in here. 6 from 8 is 2, so we put a 2 here. And then we have this conundrum. 7 from 2, well, there isn't enough in the 2 for the 7. So what we do is we reduce this 5 down to 4, which is a take away 1. And we put the 1 over here. Now we have 12. 12 minus 7 is 5. We put the 5 here, like so. And then we have 1 from the 4. 4 minus 1 is 3. So the result of this is that 5,280 minus 1,760 gives us 3,520. Now we can do this with the abacus. Let's look at the abacus. The way the Romans did it and the way it was done before people got used to doing arithmetic. We can feed in the 5,280 like we've done before. Now we subtract the 6 from the 8. Well, that's easy. You can subtract 5 there, subtract 1 there. There you've just subtracted 6. And then to subtract the 7 from here, from the 2, well, we can reduce this by 1 down to 4, put the 10 up there, and then we can subtract 7 by subtracting 5 here. 2 more there, there's 7, and that leaves the 5, and then we can subtract the 1 here, leaving us 3,520. Seems simple enough, easy enough to do. And I'll show you another arithmetic problem, this decimal. Show you that it doesn't really change if you add decimals to it. Here we have the number 17.43 minus 9.96, or maybe $17.43 minus $9.96, or 17.43 meters minus 9.96 meters, if you want to do it that way. Any way you can do it. And how we do it? Well, 6 from the 3, well, there isn't enough there, so we have to reduce that 4 down to 3. Put a 1 there. Now we have 13 minus 6, which gives us 7. And we have 9 from 3. Well, we reduce that down to 6 over here. Put the 1 over here. Now we have 9 from 13, which is 4. We put the decimal point there. And then we have 9 from 6. We put the 1 over there. So 9 from 16 is 7. And the result is 7.47. So 17.43 minus 9.96 is 7.47. And we can do this with the abacus. Okay, we're looking at the abacus, and I'm going to hold this way. Hopefully I get a good view of it. And we want to feed in 17.43. We can make the decimal point there. We can feed in 7 here, 10 here, 7 here, 4 here, and 3 here. Now we have 17.43 represented in the abacus. Now we want to subtract 9.96. Well, first we subtract the 6. Well, one of the ways we can do that is we can remove that 1 from here, add the 10 here. And now to reduce the 6 is simple. We remove 5 there, 1 there, and now we got the 7. When we want to remove 9 from 13, well, that's 3. Put that down there. But this way to add 10 over here is we put that 5 there, the 5 up here. We already removed 3. 4, 5, 6, 7, 8, and then 9. And we get the 4. And then we remove 9 from over here. Well, we get the 6 that way. Then we can remove the 10 this way by moving it over here this way. 7, 8, 9. And that gives us a 7.47 on the abacus. So that's what we can do with subtraction. But I got another neat idea. How about we do this with feet and inches? We have 17 feet and 3 inches, and we want to shorten it by 9 feet and 10 inches. Well, what can we do? Well, 10 from 3 inches, well, there's not enough in the 3 inches there. So we need to subtract a foot over here. Turn that into a 6. And we add 12 here, because there's 12 inches in a foot, not 10. 12 plus 3 is 15. Minus the 10 gives us 5. So we have 5 inches there. And then in the feet, we're back to base 10. We simply subtract 9 from 16, which is 7. So the result is 7 feet, 5 inches. We can actually do this with an abacus, which is really amazing, but it's how the Romans did it. I mean, dividing the inch into, dividing the foot into 12 inches was the Romans' idea. So we can say that this is base 12, these are the inches, and then these are feet in base 10. So we feed in 17 feet and 3 inches. We want to take 10 inches off of that. We could subtract the foot here, add 12 inches because each of these represents 6, and now we can subtract the 10 inches. There's 6, 7, 8, 9, and then we go up there, and 4, and 10, and that leaves us with 5 inches. And then we subtract the 9 feet from the 16 feet that are left. How do we do that? Well, that takes care of the 6. We subtract the 10 feet, because this is base 10, by leaving this up. Now we have 10 there. Seven, 8, 9, and that leaves us 7 feet, 5 inches. So that's how we can accomplish a subtraction with an abacus and with the paper and pencil methods. And I'll see you later when we talk about multiplication, and then on to division and to square roots. And we already have addition on the internet. You can review that. You can look at that at any time. Have a nice afternoon, and